Okay, question 2, correlation regression. So here I've done this over 2 slides, so we're going to go through each step by step to understand every result. Now, starting from the top, question 2. So Paul believes that there is a relationship between the value and the floor size of a house. He takes a random sample of 20 houses and records the value given in V pounds and the floor size in S meters squared. So we've got two random variables, V and S. Now the data were coded using x equals s minus 50 over 10 and y equals v over 100,000, and we're given the following statistics. So they're giving us all the x and y statistics, or at least most of them. Now the first one is A. Find the value sxy and value sxx. Now these are just standard. Sxy is defined as the following. You're given this in the formula book, so don't worry, but at least for result purposes, I put them up here. Now to get these results, SXY, you just plug in the XY value, which is 1474, and you plug in the sum of X and sum of Y's, which are given here. And you divide it by N. In this case, N represents 20 houses. Plug in the calculator, you should get the following result, and then repeating SXX, use SX squared minus the sum of X times sum of X, or the sum of X all squared over N. And doing the same thing, you get that result. And that's it. Now for part B, they want us to find the equation of the least squares regression line of y on x. In other words, we need to find y equals a plus bx, the standard linear regression line. And to do this, we need to first calculate what a and b is. Now thankfully, we're also given these formulas. Here we need to note that a equals y bar minus b times x bar. Y bar means the mean of y, and x bar means the mean of x. To calculate y bar, it's going to be the sum of y over n. N being 20, so 59.8 over 20 would be y bar, and x bar would be 441.5 sum of x over n over 20. Now before you do that, you need to first work out b, and to get b, we just use our results from part A, which is sxy over sxx. Divide this and you should get a value of 0.102. Plug into the first equation, you get a equals 0.746, and done. You can therefore say that your regression line y equals a plus bx, where a is going to be 0.746 and b 0.102. And that's it. You have an equation in terms of x. Done. So that's a and b done. Now let's look at the next two. So it states here that the least squares regression line of v on s, so again this is kind of a play on the previous equation and the coding, is v equals c plus ds. Now show that d equals 1020 to 3 significant figures and find the value c. This is easy. All you have to do is just realize that we're using our original y equation, and we're just substituting the value for y given in the coded part as v over 100,000. So replace y with v over 100,000 and replace x with s minus 50 over 10 from the top. Now all you have to do is just literally tidy this up. So what I did here is that I just, firstly expanded the bracket, solved it, and when you expand all this, and oh yeah, by the way, it cut off over here. When you expand this and collect like terms and times everything by 100,000, you should get basically v equals 23,600 plus 1,020s. This is just algebra. This is just expanding the bracket and collecting like terms. Okay, that's easy. Now D, estimate the value of a house with floor size 130. One thing to know about this question is that you just plug in a value. So the floor size is 130. If we look back at the top of the first paragraph, it states that the floor size is given by S. So just replace S from part C with 130. So you get 23,600 plus 1,020 times 130, and you should get this result: 156,200 pounds. Okay, all good. Now let's move on to the next slide. So E. Interpret the value of D. Interpret the value of D. So D actually came from the previous question. It's this D here for the DS. So this D we got was 1,020. And just understanding the context of this question, this is just a relation between houses, the value of the houses and the floor size. So D is next to S, and I said here that for every unit of the floor size, the value of the house increased by 1,020. So literally for every square meter added, your house increases by exactly 1,020 pounds. If they ask you to find the value of C, or A in this case, of C, you would say that the initial value of the house is 23,600 pounds. or the constant value of the house is £23,600. So as long as it's like that. Now, last part. So Paul wants to increase the value of his house. He decides to add an extension to increase the floor size by 31 meters squared. Now notice how he said this. He wants to increase the floor size by 31 meters squared. So all he wants to do is take this S and increase by 31. So he's going to write S plus 31. So our new variable is here, S plus 31. Now this one is quite okay. All you have to do now is literally expand this and collect like terms. So expand this, you get 1020s plus, and then multiply by 31, and then add it to the original, you get 55,000, and so on. So that's easy maths. Now it says here is to estimate the increase in the value of the house after adding the extension. Well, if you compare this new V equation to the original equation here, you can see that the value from 23,600 has increased to this, and the increase is you just subtract it and you get 31,620. Done. That's literally all you have to do, guys.